February 20, 1943, north of Kasserine Pass, Tunisia. The official battle reports would never fully convey what German tank commanders witnessed that morning. American Sherman tanks were executing maneuvers that defied everything the Wehrmacht believed possible, particularly without visual coordination. Through the haze of dust and smoke over the North African desert, 5 Sherman tanks, separated by rough terrain and with no direct line of sight, advanced toward German positions with uncanny precision. No signal flags, no flares, no dispatch riders relaying messages, yet the tanks moved as one synchronized unit. Each crew covered the blind spots of the others, perfectly aware of their comrades' locations. Inside German Panzer IVs, equipped with FUG-5 radios, commanders struggled to hear even their own leaders over static that drowned out orders. The 10-watt German transmitters, considered cutting-edge a decade earlier, barely worked beyond a few hundred meters when in motion. Most German tanks only had receivers, unable to transmit reports or call for assistance. The Americans, however, were using a technology the Germans didn't even know existed. Every U.S. tank carried a frequency modulation, FM, radio, crystal-controlled for precision, transmitting at 25 watts, and delivering voice clarity that cut through engine noise and battle chaos effortlessly. Thousands of miles from Detroit's assembly lines, one of World War II's most decisive technological edges was emerging, not through armor or firepower, but through invisible radio waves that connected every American tank crew in a unified network the Wehrmacht couldn't comprehend. This revolution had begun on July 22, 1941, when the U.S. Army standardized the Signal Corps radio sets SCR 508, SCR 528, and SCR 538 for all medium tanks. While German forces were sweeping through the Soviet Union, relying on limited command-to-unit communication, American engineers at the Galvin Manufacturing Company, later known as Motorola, were developing FM systems that would render German equipment outdated. The design team included Daniel E. Noble, who envisioned FM's military use, and Henryk Magnuski, the lead RF engineer who overcame the technical challenges of adapting advanced electronics to tank conditions. Their system, weighing about 181 pounds, turned every Sherman into a node in what was effectively the world's first mobile battlefield communication network. The BC 604 transmitter generated 25 watts of power, 2.5 times more than the German FUG-5's output. Operating between 20.0 and 27.9 MHz, it featured 10 preset, crystal-stabilized channels. Dual BC 603 receivers in the SCR 508 allowed commanders to monitor multiple frequencies at once, a crucial advantage during combat. But the true innovation lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed to the U.S. military, virtually eliminated the interference that plagued traditional amplitude modulation. While German tank radios picked up every electrical pulse as noise, American FM radios maintained clear, reliable voice transmission even under artillery bombardment. When Operation Torch began on November 8, 1942, American armored units landed in North Africa near Safi and Fadala, equipped with SCR 508 radios. These would soon prove vastly superior to anything the Germans had. Despite being the Wehrmacht's most experienced armored corps, the Afrika Korps suffered from severe communication handicaps. A standard German tank platoon of 5 vehicles had only 1 or 2 tanks with full FUG-5 transceivers capable of both sending and receiving. The rest carried FUG-2 receivers only. They could hear commands but not reply or relay battlefield updates. This forced German platoons to rely on a strict chain of command. The lead tank gave orders, and subordinates responded through action, not speech. When command tanks, easily spotted by their multiple antennas, were destroyed, entire platoons were left without coordination. This weakness became critical when facing American forces, where every tank could assume command instantly. The Battle of Kasserine Pass, February 14 to 24, 1943, offered the first major demonstration of this American communication advantage. Although the engagement was tactically a German victory, it revealed capabilities that left Wehrmacht observers astonished. During the confused fighting, scattered elements of the U.S. 1st Armored Division managed to maintain coordination across more than 50 miles of battlefield. Tank crews who had never met before synchronized attacks, warned each other of enemy threats, and requested artillery support through remarkably clear FM radio communication. German signals intelligence units intercepted these American transmissions and were struck by their exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported that American units maintained contact at distances where German radios produced only static. Even more alarming to them was the realization that nearly every American tank had full transmission capability, not just command vehicles. German FUG-5 radios, operating on amplitude modulation within the 27.0 to 33.3 MHz range, suffered from fundamental design limitations. Their 10-watt transmitters could reach only about 2 to 3 kilometers under perfect conditions, and this dropped to mere hundreds of meters when the tanks were moving. Every spark plug, motor, and electrical system in the vehicles created interference that AM radios couldn't filter out. By September 1943, American armored units had reached Italy, terrain that should have neutralized their radio advantage. Instead, FM technology became even more valuable. The SCR 508's frequency modulation handled the echoing and multipath interference of mountain valleys far better than AM systems. American tanks coordinated maneuvers through rugged landscapes where visual signals were useless and German radios failed completely, especially during the advance toward Cassino. American armored units displayed coordination the Germans couldn't comprehend. Tank platoons separated by ridgelines executed joint attacks with precision that German doctrine claimed was impossible without line of sight. After-action reports from the 1st Armored Division described normal coordination at distances where German systems transmitted only noise. On June 6, 1944, as Sherman tanks rolled ashore at Normandy, their SCR 508 radios maintained seamless communication with naval fire support, something German technology could not achieve. However, fighting in the hedgerows soon exposed a critical flaw. Tank radios couldn't communicate with infantry sets that operated on different frequencies. The infantry's SCR 300 worked in the 40.0 to 48.0 MHz range, incompatible with the tank's 20.0 to 27.9 MHz systems. This gap proved deadly in the bocage terrain, where German infantry armed with Panzerfausts could approach American tanks undetected, while nearby U.S. soldiers had no way to warn them. American ingenuity solved the issue within weeks. Tank crews mounted EE-8 field telephones in ammunition boxes welded to the tank exterior, directly wired into the tank's internal communication network. By Operation Cobra in late July, this simple innovation revolutionized tank infantry cooperation. Between July 25 and 30, 1944, Operation Cobra fully demonstrated the power of American radio superiority. The 2nd Armored Division, under Major General Edward H. Brooks, coordinated over 200 Sherman tanks using interconnected radio networks that allowed for unprecedented battlefield control. German defenders from the Panzer Lehr Division faced an opponent that seemed to anticipate every move. American tanks reacted instantly to reports from units miles away, and artillery strikes, coordinated through tank radios, arrived within minutes of spotting the target. The contrast between American and German capabilities was striking. Panzer Lehr, once the elite of Germany's armored force, found itself crippled by communication failures. Many tanks operated with no radios at all, depending solely on visual signals in terrain where visibility often fell below 100 meters. The few radios still functioning were plagued by interference and limited range, making coordination nearly impossible. The irony was unmistakable. Germany had pioneered the use of radios in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on equipping every tank with a radio as early as the 1920s. In his 1937 book Achtung, Panzer, Guderian emphasized communication as the foundation of armored operations. His innovations in radio coordination had once revolutionized tank warfare. Yet by 1943, Germany's industry could no longer supply the very equipment his doctrine demanded. Production figures highlighted this crisis. In 1943, Germany built around 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Most were reserved for command vehicles and assault guns, leaving regular tanks with minimal or no radio capability. The Soviet situation was even worse. Despite the massive production of T-34 tanks, most entered battle without radios at all. Soviet tactics relied on flag signals and pre-planned operations, often with disastrous results during the German invasion of 1941. By 1943, Lend-Lease aid brought some improvement. American SCR-508 radio sets began equipping Soviet command tanks, but even by the war's end, only about 25% of Soviet tanks had radios. This stood in stark contrast to the United States, which achieved 100% radio deployment across its armored forces. At Motorola's Chicago factory, the scale of American industrial mobilization reached its peak. Before the war, the company specialized in car radios, but it completely retooled for military production, solving new engineering challenges along the way. Each SCR-508 unit contained over 2,700 precision components, including 474 capacitors, 385 resistors, and crystal oscillators that maintained frequency stability despite the heat, vibration, and stress of combat. Production numbers reflected this achievement. 1942, 3,800 SCR-508 units. 1943, 11,400 units. 1944, 24,000 units. In total, more than 50,000 tank radio sets were produced, enough to equip every one of the 49,324 Sherman tanks built during the war, a feat unmatched by any other nation. The SCR-508's advantages extended beyond frequency modulation. Its crystal-controlled stability allowed tanks to preset channels before combat and maintain alignment during operations. In contrast, German Fug-5 radios, which relied on manual capacitor tuning, often drifted off frequency. The dual-receiver setup of the SCR-508 let commanders monitor both platoon and company nets simultaneously, ensuring smooth command flow. The BC-606 intercom system integrated with the radio, allowing every crew member to alert the commander immediately to battlefield threats. Throat microphones and noise-canceling headsets ensured clear communication even amid explosions and engine noise. Many German tanks lacked intercoms entirely, forcing crews to shout or use physical gestures. Power management also gave the Americans an edge. The SCR-508 could operate on either 12 or 24 volts, automatically adjusting to available power. Its dynamo torque supply provided filtered, steady current that eliminated static. German sets, drawing directly from the tank's electrical system, suffered interference from every spark and surge. This widespread radio integration reshaped American armored doctrine. Flexible combat commands, task forces organized for specific missions, depended on reliable communications. Commanders could assemble ad hoc battle groups from multiple units, confident that radio compatibility would ensure coordination. German forces, bound by rigid organization and limited communication, couldn't adapt with the same speed. During the Battle of Aricourt in September 1944, the 4th Armored Division faced several German Panzer brigades equipped with the formidable Panther tank. Despite the Germans' superior armor and guns, American radio coordination proved decisive. Sherman crews instantly reported enemy positions, tank destroyers received firing data from unseen allies, and artillery observers in command tanks called down accurate barrages within minutes. Over 3 weeks, the 4th Armored Division destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that defied expectations. Throughout the war, German intelligence consistently underestimated the role of American radio technology. Their reports often noted the high level of coordination among U.S. tank units but mistakenly credited it to training rather than communications superiority. A captured German intelligence assessment from September 1944 summarized this misconception. American tank units display strong radio discipline and coordination. This seems to result from extensive training and strict command methods. They never realized that the real advantage was invisible, carried on the airwaves between every American tank. The German report on American radio use concluded that their coordination came from communication procedures, completely missing the underlying technological advantage. German tactics never adapted to U.S. capabilities. They continued targeting what they assumed were command tanks based on antenna arrangements, unaware that every Sherman could direct battlefield actions. Their ambush plans relied on the belief that American units would lose control once separated, Not realizing radio contact allowed them to maintain cohesion even without visual connection. March 1945. As American forces approached the Rhine, their communication dominance reached its height. The capture of the Remagen Bridge highlighted the extraordinary speed of U.S. command and control. When the 9th Armored Division discovered the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, units across the front were repositioning to seize the opportunity. German forces, reliant on telephone lines repeatedly destroyed by Allied aircraft, couldn't respond with similar speed. American radio coordination established an unbreakable defense around the bridgehead. Tank platoons from different battalions integrated effortlessly, coordinating their fire through the radio network. German counterattacks, hampered by communication failures, arrived piecemeal and were destroyed one by one. April 1945. The encirclement of the Ruhr pocket marked the peak of American communication superiority. Armored columns from the 1st and 9th Armies executed a massive double envelopment entirely through radio coordination. Inside the pocket, 325,000 German troops were trapped, largely because their communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically eliminated German communication centers. Wehrmacht units lost all contact with higher command and with each other. Field Marshal Walter Model's final transmissions before total communication failure captured the situation. No contact with neighboring units. No communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority also shaped the psychological side of tank warfare. U.S. crews fought knowing they were never alone. Even when cut off, they remained connected through reliable radio links. German tank crews experienced the opposite, deep isolation. Unable to communicate, they fought individual battles within larger conflicts. Otto Carius, one of Germany's top tank commanders, described in his memoir Tigers in the Mud the enormous difficulty of fighting with limited communication, though he focused more on tactics than on the communication gap itself. The strategic effects extended beyond single battles. American advances during 1944-45 maintained momentum largely through radio coordination that German forces couldn't match. Patton's Third Army drove across France with radio networks that maintained control across hundreds of miles. German commanders consistently underestimated U.S. operational tempo because they couldn't imagine such communication efficiency. Heinz Guderian, serving as Inspector General of Armored Troops, recognized the issue but had no means to fix it. In a December 1944 memorandum, he admitted that American coordination nullified the advantages of German tank quality. After Germany's surrender, U.S. technical intelligence units examined captured German equipment. Their findings confirmed what battlefield experience had already shown. German tanks often had better armor and guns, but their communications were fatally outdated. U.S. Army Technical Intelligence Report No. 176 concluded that German tank communication systems were about 5 years behind those of the Americans. The lack of FM technology, limited radio distribution, and poor electrical noise suppression left them at a severe disadvantage. Soviet assessments came to the same conclusion. When given access to captured German vehicles, the Red Army chose to model its post-war radios on American designs rather than German ones. Production data underscored the scale of the American accomplishment. SCR 508/528/538 radios produced 50,000 plus units. Sherman tanks produced 49,324 units. Radio deployment rate 100%. Transmission power 25 watts. Frequency stability crystal controlled plus or minus 0.01%. Effective range 7 miles moving, 10 to 15 miles stationary. In contrast, German FUG-5 radios produced 6,000 units. Medium and heavy tanks built 12,000 units. Full transceiver installation 20%. Transmission power 10 watts. Frequency stability plus or minus 1%. Range 0.5 to 1 mile moving, 2 to 3 miles stationary. Communication Effectiveness Comparison. Average American Fire Mission Response, 3 to 5 minutes. Average German Fire Mission Response, 15 to 30 minutes. American Tank Coordination, 100%. German Tank Coordination, 20%. The radio superiority of the Sherman tank established principles that still guide armored warfare. Modern main battle tanks use digital communication suites that evolved directly from the SCR-508, analog replaced by digital, but with the same goal: universal connectivity and dependable coordination. When the Bundeswehr was re-established in the 1950s, it made communications a top priority based on lessons from World War II. Every Leopard tank produced since has included advanced radio systems. A Bundeswehr training manual summarized the lesson clearly. The defeat of superior German tanks by less advanced American tanks with better radios shows that information dominance outweighs platform superiority. Modern warfare has repeatedly validated this truth. In the 1991 Gulf War, coalition forces with superior communication systems destroyed Iraqi units equipped with individually stronger, Soviet-designed tanks but inferior radios. Again in 2003, U.S. forces proved that network-centric warfare triumphs over platform-centric warfare. The story of American Sherman radio superiority represents a victory in the electromagnetic spectrum, an advantage more decisive than superior armor or firepower. German tank crews fought their war unaware of the revolution happening around them, realizing too late that every Sherman was not merely a tank, but part of the first true battlefield network in history. The SCR-508 radio transformed the M4 Sherman from a capable medium tank into a vital component of a connected weapon system that linked every U.S. tank on the battlefield. This transformation proved more important than any upgrade in armor or gun caliber. Each Sherman carried the real tools of victory, not only its 75 mm cannon or sloped armor, but the 181 pounds of radio equipment that connected its crew to all others. That connection created a collective intelligence no individual German tank, however advanced, could equal. From Kasserine Pass to the Italian mountains, across France's hedgerows, and into Germany's final battles, American tanks demonstrated a level of coordination German doctrine had claimed was impossible without direct visual contact. The Wehrmacht never developed a countermeasure, largely because it never fully grasped the scope of the technological divide. Field Marshal Wilhelm Keitel's supposed remark at Germany's surrender: "We knew how to build better tanks, but you knew how to make them work together," whether factual or not, captured a core truth. America had built not just 49,324 Sherman tanks, but 49,324 interconnected nodes in the world's first armored communication network. The revolution in warfare that historians now call network-centric combat began in 1942, when the first Sherman with an SCR-508 rolled into action. From that moment on, the side with better communication would always defeat the side with better machines. The network would overcome the platform, and the connected would always prevail over the isolated. This transformation was largely invisible to the Germans. They saw American coordination but misunderstood its source until it was far too late. By the time they realized every Sherman had communication abilities most of their own tanks lacked, the war's outcome was already decided. The German military's failure to recognize and address its communication disadvantage stands as one of the greatest intelligence oversights of the Second World War. Despite countless encounters proving America's coordination advantage, German leadership never corrected the issue. They continued producing superior tanks that fought as isolated units, while the Americans built standard tanks that fought as cohesive teams. In the end, the electromagnetic waves transmitted by SCR-508 radios proved more decisive than the 88 mm shells fired by German guns. The power to coordinate, share information instantly, and fight as one unified force outweighed any advantage in armor or firepower. The radio superiority of the Sherman tank forever changed the nature of warfare, establishing the enduring principle that in modern battle, connection means survival, and isolation means defeat. German troops learned this truth the hard way across 3 continents, realizing too late that American strength lay not just in numbers, but in technological mastery of the invisible spectrum that truly decided the war.